Welcome to our presentation. I'm Clint Wadley, and we have Sid and Doug and Prima here. We are group 20 or group 7 of the What the Hack challenge. That challenge is to use the sensors within mobile devices in some novel way. And what we've chosen to do is something we've called TapFA, and that is build a two-factor authentication app that's similar to Duo, but instead of having to unlock the device and accept the push notification with the touch screen, you're actually able to haptically tap the device to accept the push notification. So I will turn the time over to Sid to go over our project goals.
Thanks, Clint. So our overall goal is to develop a two-factor authentication method, TapFA, that enables our users to approve a push-type 2FA request more conveniently by tapping the back of their mobile device in a pre-recorded pattern. We can break down this overarching goal into 3 components of technicality, usability, and security. For the technical component, we want to develop a consistent mobile application that ensures the user can record a tapping pattern and use it with reliability. As for the usability component, we want to improve on the usability of the existing 2FA technology by utilizing the intuitive and time-saving method of tapping the body of the mobile device and potentially enhancing the accessibility for the visually impaired. Last but not least, for the security component, we definitely want to maintain the level of security required for any 2FA technology. Our project plan includes 4 phases. In phase 1, we finished project ideation and prototyping. In phase 2, we are in progress of developing a minimum viable app. In phase 3, we want to conduct usability testing via experiments with users. In the last phase, phase 4, we will update the software based on the user feedback and then before deliver our final deliverables. And here is our forward-looking project plan. Starting next week, which is the week 4 of our overall project, we will work on server app integration testing after we finish the minimum viable app, and we will submit the project update write-up. Starting week 5, we will start with experiment design, which could run parallelly with the server app testing if needed, before we conduct experiments in week 6. In week 7, we will collect the quantitative and qualitative research data. For example, the quantitative data could be the time it takes for the users to successfully approve a request to gather whether our app has made their efforts more convenient. And for qualitative data, we could gather written responses from the user to gather their experience with the usability of our app. We will analyze the data before moving to week 8. Week 8 is the beginning of our last phase, phase 4. We will update the software requirements based on our results from our user experiments and update the app. And then in week 9, we will make sure that our app is updated with the usability features and also integrated testing to make sure that our app is secure. And week 10 will be where we wrap everything up with the final demo and report. And next, I'll hand back over to Clint to discuss our expected outcome.
Thanks, Sid. So the final goal of this project is to have an application, a mobile application that's similar to existing two-factor authentication apps like Duo or Authy, but with the addition of being able to accept two-factor authentication requests with a tap, a physical tap. And in order to do that, we are going to need to implement a few things. We're going to need to implement a backend server that implements an API that supports that the push-based two-factor authentication. And then we're going to leverage an existing IDP called Authentic to provide the authentication server for our site. We're going to also have an example site that will then be protected by Authentic, and Authentic will integrate with our backend server to actually perform the two-factor authentication flow to our TapFA mobile application. So here is that architecture. So similar to existing two-factor authentication clients, we'll have a client running on a mobile device, and they will register that device to Authentic, and that will in turn register the device with the TapFA backend server. Once they are registered, then they can log in. When they try to access the website, they will log in with their username and password, which will initiate the two-factor authentication flow. Authentic will send a request to our backend to send a push notification to the client. It will then send that push notification, and then by tapping or on the screen, whichever is preferable for the user, they will accept or reject that two-factor authentication request. That will go back to the backend server, and that will evaluate and authenticate that request coming from the client, make sure that it's not forged by using digital signatures. And then that will send a signal back to Authentic, either confirming or rejecting the login. And then Authentic will redirect the user to the website if the login is successful. So that is the architecture that we are planning on implementing. And I'm going to turn it over to Prima to talk about what we've done so far.
Okay, thank you, Clint. And right now, as Clint mentioned about all the architecture, if you have looked into the architecture, the main portion is the Authentic instance, which we have already developed an Authentic instance, and it's up and running in the public domain. It is right now accessible. That portion has already been done. The next one that what we are currently working on is developing a backend API, and this API is going to retrieve the credentials from the data store, which data store has already been up and running as well, similar to where the Authentic server is running. Both Authentic and the DB are available in the public domain. So the next stage, what we are currently working on is the app development. So we have picked the React Native as the technology for this app development because it is a cross-platform technology. That way, the app can be available or published to both Android and iOS devices. And here is the progress, the status. You can call it a progress or it's a status update. If you look at the green portion of it, that's what the in progress, where right now we are going to work in parallel, both developing the React Native application as well as the backend server, which is going to retrieve the credentials from the data store, and the portion of the Authentic server is done already. So I'm just handing it over to Clint.
Yeah, so I will just show you. So this is our Authentic instance that is currently running, and I can actually log into it using these credentials. We do not have 2FA set up quite yet, but this is our example website. It works. We can log into it with Authentic. And then we are also developing our backend server, just starting on that now, but we have certain functions of it already implemented, specifically this signature function that allows us to validate a signature from the device to ensure that it is a valid response. And then we're also starting to do some research as to how to actually implement our tap-based recognition algorithmically in our mobile app. And so that is also underway. Turn it over to Doug to talk about our problems that we've encountered.
Yes, thank you, Clint. Problems encountered. Tech stack React Native is new for all of our team. So application development, that's a learning curve, but we're up to meet the challenge. The second point is that we identify the correct tap detection library or algorithm. As you saw in the previous slide, there was some preliminary React code that we're finding by researching on the tap pattern detections. We're building our proof of concept for multiple detection approaches. For a third point, there are existing push-based 2FA protocols like Dual and Authy are proprietary, which means that we don't actually have access to this code, so it's not open source. And so this necessitates that we write our own backend server and authentic stage plugin. So thank you for your time. Then this concludes our project update on TAP FA haptic two-factor authentication.